All right, welcome. This is Unit 1, Lesson 5. We are talking about the distributive property today. Okay, make sure you get all this title slide written down. Remember, your objectives are right here. Use the distributive property to simplify expressions. And then we're also going to simplify expressions by combining like terms. Okay, let's go ahead and jump right into it to get started. Wouldn't be a lesson from Mr. Ayers without a fun fact of the day, of course. So here's our fun fact of the day. Our eyes are always the same size from birth. That never changes. But your nose and ears never stop growing your entire life. That's why people make fun of old man ears, like Mr. Ayers has, okay? Because when you're getting to be an old man, you've been living a long time, your ears get really big, and so does your nose. Okay, so we got the little Pinocchio picture here to represent the nose growing big. All right, let's go ahead and get started with the lesson. Okay, example 1 here, we've got a few problems that ask us what is the simplified form of each expression. That means they just want us to rewrite it, okay, as simple as we possibly can. This is where the distributive property comes into play. We use the distributive property when we see parentheses and a number directly attached to the parentheses without a sign in between, okay? It means we're multiplying. It doesn't matter if the number is in front or if it's behind the parentheses. Okay, what we do when we distribute is we pass out that number to everything in the parentheses. Okay, it's like if Mr. Ayers was going to pass out Jolly Ranchers to the class. It wouldn't be fair if I just passed it out to 5 people or 10 people. It would only be fair if I passed it out to the entire class. Okay, when we distribute, we need to make sure that we are fair to each part of the parentheses. So I'm going to pass out what's outside to each part. Okay, and I always like to remind myself of that by drawing little lines to show that that's what I'm going to do. Okay, now I'm going to rewrite this, okay, because when I distribute I am multiplying, so I'm going to take 3 times x. I'm going to keep the addition sign, and then I'm also going to do 3 times 8. Okay, now this is a step of work I'm only going to do for the first example because it's kind of unnecessary. I just want to show you on this one what we're doing. So please make sure you write this in your notes. I won't expect to see this much on your assignment. But notice I'm taking 3 times x and keeping my add sign and then taking 3 times 8. Okay, so now I just need to simplify that. Well, I write 3 times x as 3x and plus 3 times 8 is 24. Okay. Now I am done simplifying because I cannot combine 3 x's and 24 of something when I don't know what the something is. Okay? So I am done here. Now same thing here on the next one. Okay? We are going to distribute. Again, I've got parentheses with a number directly attached to it. So this time it's just kind of backwards. So I'm going to distribute the -7 to both places. So I'm going to take -7 times 5b, which is -35, because -7 times 5 is 35, with the b after it. Okay? Then I am subtracting. Now I have to take -7 times 4. -7 times 4, well that's -28. And I put the parentheses there, okay, to denote that we got minus a negative. Now, we're never, ever, ever going to consider it simplified if we have minus a negative. Okay, so we're going to do what we've learned to do with subtraction problems and change it to an addition problem when this is the case. Okay, so it's going to end up being -35b. We change the minus sign to a plus, and we change -28 to its opposite. Now again, I cannot add something that is b's to something that has no label, so I am finished on that problem. Done. Okay, now we move on to the last example. Okay, we've got a negative sign outside of the parentheses. This confuses some people, and it's really not all that difficult. Okay, so here's what we do. Here's how we think of this. A negative sign really means the opposite of something. So for example, this number in here is the opposite of 2, which we know is -2, or that's how we say it. Okay, because it's kind of shorter to say that way. So, but we can think of negative signs as the opposite of. So really, this negative sign out here means I want the opposite of the stuff that's in here. Okay, I'm going to pass out the opposite to each part of this. Alright, so what I'm going to do is I'm going to attach the negative to this to pass it out to the -2 and to the x. Okay, notice, just like usual, I skipped the sign, okay, because we skipped the sign all the way through. We can't take 3 times a plus sign or something like that, so we're not going to distribute this negative sign to that, okay? But we're going to do the opposite of negative 2, which is positive 2. We're going to keep our sign in the middle the same, okay? And then we're going to do the opposite of x, which is what? Negative x. There you go, 2 plus negative x. Or, okay, and this really is only a good idea when you got a plus sign in here, okay? Or we could say that this is the opposite of negative 2, which is positive 2, and the opposite of adding x, which is subtracting x. Okay? That's really only good when it's straightforward. This one is better conceptually for you, though. Okay? But I'll take either answer in that case. Now you have to be careful if you go this method, though, okay, because the signs can get mixed up. I really like you to keep the sign the same. Okay, let's keep moving on to some other examples here. Okay, you get a problem like this. Example 2 says, rewrite the fraction as an addition or a subtraction problem. Okay, when we have an addition or subtraction on top of a fraction or on the bottom of a fraction, we can really split this, okay? What this does is it splits the top into 2 parts, okay? So here's all I need to do. I need to split my top parts. So I'm going to just write 7x plus 2 like this, okay? But when I do that, because of fraction rules that we're not going to get into right now, okay, but this is something you just need to know, is that if I split the top and bottom like this, I've got to put the denominator in both places, okay? So I have to put this over 5 and this over 5. So it becomes 7x over 5 plus 2 over 5, okay? This is knowledge to get from here to here. This is knowledge that you will need as the year progresses, okay? That's a big deal in algebra class. Okay, and I can give you a quick example of why this works, I suppose, here. Let's pretend we did 1 plus 3 over 4. Well, if you were going to use the order of operations, we'd just solve this, right? We'd say, well, 1 plus 3 is 4, and we put it over 4, and 4 divided by 4 is 1. Okay? Well, we can use this splitting rule here and split the 1 plus 3. And you'll notice the only way that we can get this same answer is to apply this 4 to both of these. Because if I make this 1/4 and this 3/4, well, 1/4 plus 3/4 is 1, which is the exact same as 4 divided by 4. Okay, so there's a real easy example of why we have got to apply 4 to both of those. Okay, are we making sense? We're going to go ahead and move on to the next problem here. Oh, whoops, I forgot to box my answer. My original answer, whoops, I didn't want to move the screen. My original answer was right here. So, there we go. Okay, now we're going to move on to the next example. Okay, example 3 says to use the distributive property to make this problem mental math. Okay, so essentially what this is saying is we want to rewrite this problem so we got something outside the parentheses and 2 things inside that are combined, either by addition or subtraction. Okay, because this has been our distributive property setup so far. Right, either something like that or something with a minus sign in it. Okay, so basically we want to split this into 2 things that are added or 2 things that are subtracted that are easy to multiply by, because then we can do this problem in our head without having to write it out. Okay, so basically what I'm looking for is, what is a number around $4 or 4.95 that's really easy to multiply by? Okay, and I'm not going to mess with the 8. Well, I know that 5 is really easy to multiply by, right? Okay, but I also know that 495 is not quite the same as 5. Okay, but if I take away an amount, I can get to 495. And how much would I have to take away from 5 to get down to 495? Well, that would be like 5 cents, right? 0.05. Okay, so all I did was I rewrote this as 8 times like $5 minus 5 cents. And the reason why I did that and I picked those numbers because I know 8 times 5 and I know 8 times 5 cents to figure that out. Okay, so really 8 times 4.95 is going to be the same as 8 times 5, which is 40, minus 8 times 5 cents, which is 40 cents. Okay, and $40 minus 40 cents, well, that's $39.60, or 39.6. Whoop, I don't need a dollar sign because there's no dollar sign there. That's $39.60. Okay, and all of a sudden that became a mental math problem if I think about it in terms of numbers that are easy to multiply by. Okay, but again, the key is that these two numbers have got to be added or subtracted to come up with this number. Okay, but that's how we would show this. So on a problem like this, I would expect to see you break it apart into a step like this, and then go ahead and solve it out and get an answer. Okay, but this is really the key part that I would expect to see on those kind of problems. Alright, and let's go ahead and keep on trucking along here. Hey, you guys have made it to the last example here, okay? Example 4, we're going to simplify this by combining like terms. Well, the very first thing I see when I look at this problem is I got a plus 12x out here. Okay, but order of operations says I have got to do parentheses first, or get rid of the parentheses. So I'm going to look at this. I cannot combine these things in here, because again, one has an x and one does not. So the only way I can get rid of the parentheses is to distribute this. And the only reason I can distribute this is because this number is being multiplied by all this. It's directly attached to the parentheses. Okay? So the very first thing I'm going to do is distribute this out. I'm going to rewrite this nice and big here because I like to have a little space. So again, order of operations. We talked about GEMDAS, right? Grouping symbols. I got to get rid of the parentheses first. And again, since I can't combine these, the only way to get rid of the parentheses is right here, distributing. So 2 times negative 3x, well, that's negative 6x's. Then I got my minus sign. Then 2 times 4 is 8. Okay, since I distributed, I am now done with the parentheses. So I just throw the rest of this on the end here. Now I'm looking for like terms. Means what are things that are alike that I combine? And basically what that means is they've got to have the exact same label, the same variable parts, the same letter parts, exactly. Okay? Well, since this says x and this says x, I can combine those. I can combine negative 6x plus 12x, and negative 6x plus 12x is 6x. Okay? Different signs. One's negative, one's positive, so we subtract the two numbers and keep the sign of the one there's more of. Okay? And I didn't do anything with this minus 8, so I'm just going to bring it on down. And I am not allowed to do anything farther because x's are over here, and there's no label over here. So I am done. Okay? That is it. So, it would take some questions if I was here. However, I'm not there, so you'll have to ask me in class when I get back. Alright, have a great rest of the day. Happy homeworking.